Whether screen is visible?
Yes, sir.
Okay, thank you. In last lecture, uh, we have covered the brief introduction related to our subject, in which you have to think about the what will be the course objective, what will be the course outcome. Then we discuss about the content of this syllabus or this subject, that is a non-conventional machining. It is having the two sections, each section having the three chapters. We have to study six chapters considering the two sections, right? Now, from today, we'll start with the syllabus, the unit number one, that is the overview of non-conventional processes. In this chapter, you have to study what is the non-conventional machining processes. To start with the non-conventional machining processes, you must know what is the process. Means you must know what is the manufacturing process or machining process. If you are considering this machining process, it will be divided into two types, primary machining and secondary machining. So this machining process can be divided into two parts. First, that is the primary, and second, that is the secondary machining. And whatever the manufacturing process, those are removing the material, it will become under the category of the secondary process. Then we go for the what is the conventional machining and non-conventional. If you are considering the conventional machining, you imagine that there will be lathe machine, there will be a milling machine, there will be a drilling machine. How material is to be removed from the workpiece in order to get the desired shape or in order to perform the desired operation on that workpiece? Which kind of a tool is to be used? What will be the material of that tool? How force is to be applied? So, if you are considering about the conventional machining process, a picture of lathe, drilling machine, milling machine, that will be appear in front of your eyes. That is, in case of conventional machining, you require the cutting tool, and the material of that cutting tool, it is a more harder than the material of the workpiece. Then and then only the cutting tool, it will remove the material from the workpiece. Then what is the non-conventional machining? If you are consider conventional and non-conventional, in case of a non-conventional machining, we are utilizing certain sources of energy in order to remove the material from the workpiece. Instead of the tool, by using the different sources of energy, it may contain mechanical energy. If you are considering mechanical energy, there will be process of erosion, friction, right? If you are considering the electrical energy, then by using the electrical energy, we can generate the heat, and that heat is utilized to remove the material from the workpiece. Even third one, that it will be chemical energy. Means by using the chemical energy, by carrying out chemical reactions, you can remove the material from the workpiece. Electrochemical machining, right? Electrolysis process you might have studied in 12th or in a previous uh, subject like physics, whatever it may be, right? And one more source of energy, that is a thermal energy. Thermal, it is meant for the heat. So, by using that heat energy, you can melt or vaporize that workpiece material. Due to high temperature, the material it will be get first of all melt and then it will be get vaporized. So that material is to be removed from the workpiece. That is, in case of non-conventional machining, you doesn't require the tool to remove the material from the workpiece. There is a basic difference between conventional and non-conventional machining. That is the first part that is I have covered. What is a non-conventional machining? Before going to this non-conventional machining, you must know what is the manufacturing process. Then primary, secondary manufacturing. Then you know conventional machining. Then you go for the non-conventional machining. Now, in this non-conventional machining, why it is to be needed? You have to consider why it should be required. So we will see in detail what is the need to go for non-conventional machining. Then second point, classification. How such a non-conventional machinings are to be classified? What is the criteria for the classifying of such non-conventional machining? Third point, it will cover comparison with the conventional machining. Now we are dealing with the non-conventional machining, so that we are comparing it with the conventional machining process. And lastly, we have to give brief overview of all these techniques, all these non-conventional machining processes. Means here we have to just study or overlook what is the working principle, what is the block diagram of all kind of the non-conventional machining processes or techniques. So you write the name of the unit number one, that is the overview of conventional process. Write it contains non-conventional machining processes where you have to study its need, classification, comparison with conventional machining process, and last, that is the overview of all techniques. You take 1 minute to write this. Okay, I think is it over, right? Can we move forward? Now we will starting with the first point, that is the need. Why we need the non-conventional machining process. Yes. That is the first point. Why do we need here? The second, another name for the non-conventional machining process, that is the advanced machining processes. It also called as the advanced machining processes. You may call non-conventional machining process as the advanced machining process. As we discussed that every manufacturing process it mainly divided into two parts. First one, primary manufacturing process, and second one, that is a secondary manufacturing process. As far as primary manufacturing process is to be concerned, such kind of manufacturing processes are to be provided in order to provide basic size and shape to the material as per the requirement of the design, as per the designer's requirement. Means by observing the drawing, we can providing the shape as per the size to the workpiece by observing the drawing which is made by the design engineer. So which are the such kind of the processes? The primary manufacturing processes, it includes casting, forming, and powder metallurgy, etc. These are the primary manufacturing process because they are only providing basic size and shape. They are not related with accuracy. They are not related with the final shape, tolerance, dimensions. Means approximate shape is to be formed by such kind of the manufacturing process. Are you getting? Primary manufacturing process, they are giving only basic shape and size. Which are such processes? The example of such process, that is the casting, forming, powder metallurgy, right? Then second type of the manufacturing process, that is the secondary manufacturing process. Such process that will provide the final shape and size. Here, what is the difference? In primary basic with the shape, and in secondary it will provide the final shape and size with tight control on dimensions. Means tight control on dimensions, that is nothing but the with a close tolerance they are providing the final shape and size. At the same time, they are providing good quality of a surface characteristic. What is surface characteristic? It may called surface roughness or surface finish. Means in case of a secondary manufacturing process, we can provide final shape to the workpiece with a very tight control on dimension or very high accuracy of dimension. With dimension, we can also maintain very good surface characteristic like very smooth surface finish. So whatever the material removal processes are there, all are come under the category of the secondary manufacturing process. Means turning process, drilling process, milling process, grinding process, by which we can remove the material from the workpiece in order to provide a final shape with a good surface finish to the workpiece. So whatever the material removal processes, all are come under the category of a secondary manufacturing process. Just you mark a point, that is a manufacturing process. It will divide it into two types. Right, first type, that is primary manufacturing process. You can write it will provide basic size and shape. Example that is casting, forming. Second type, secondary manufacturing process. It will provide final shape and size with a good tolerance and a good surface finish. And whatever the material removal, all processes, they are come under the category of a secondary manufacturing. Are you getting? Yes, please reply. Hello? Hello? My voice is audible? Screen is visible?
Yes, sir.
Okay. Are you getting these points? Primary manufacturing and secondary manufacturing? Okay. Now, all the material removed processes are come under the secondary manufacturing process. Now, which are such material removing processes? How they can be divided? Such material removal processes can be divided into two types. First one, that is a conventional machining process. and second one, that is the non-conventional, or it may be called as a non-traditional, or it may be called as a advanced machining process manufacturing. Now, what is the conventional machining process? In conventional machining process, they are mostly remove the material in the form of chips by applying force on the workpiece with a wedge-shaped cutting tool, whose material is harder than the material of the workpiece. Such processes are called as a conventional machining process. Are you getting? Conventional machining processes means in such kind of the process we can remove the material from the workpiece in the form of chips, and for removing the material you require a cutting tool. It will be a single point cutting tool or wedge shape cutting tool, and the material of that cutting tool, it must be harder than the material of the workpiece. Such processes are called as a conventional machining process. Which are the examples for the conventional machining process? That is the turning, boring, shaping, slotting, grinding, milling, drilling. These are the conventional machining process. Now, second part of material remove process, that is a non-conventional machining process, or it may be called as a non-traditional machining process, or it may be called advanced manufacturing process, advanced machining process. What is that? It is defined as group of process that remove the excess material from the workpiece by various techniques, which may involve different kind of energy like mechanical energy, thermal energy, electrical energy, chemical energy, or combination of these energies. But such processes does not use a sharp cutting tool that is needed in case of a traditional machining processes. Means in non-traditional or non-conventional machining process, it does not require the cutting tool. They are utilizing different kind of the energies in order to remove the material from the workpiece. Which are such non-conventional machining processes? AJM. AJM means abrasive jet machining. EDM, that is the electric discharge machining. ECM, electrochemical machining. LBM, that is nothing but laser beam machining. Likewise, EBM, that is the electron beam machining, etc. Such are the non-traditional, non-conventional, or advanced machining processes. Write some points related to the conventional machining process and non-conventional machining process. Take a 1 minute to make a point. Okay. Now, if you are considering the field of engineering, there are n number of materials those are utilizing in a branch of the engineering, field of the engineering. Which are those materials? Metals and its alloys, plastic and composites. In certain cases, we may use the ceramics. Now, majority of these materials are more popular, right? And they are having a certain advantages with over the each other. But there will be certain materials, those are having very hard, those are having very flexible, those are having very brittle. Now there will be a challenge that how to machine such kind of the material. If you are considering the titanium, it is a very hard material. How to machine? If you consider the glass, it will be very brittle. How to machine it? If you consider rubber, it will be very flexible. How to clamp it on machine and how to remove the material? That will be very challenging one. So, like such materials, plastics, composites, ceramics, right? They are very difficult to machine by using the conventional machines like a lathe, grinding, right? Milling machines. So, in order to machine such a material, you require certain solutions. Now, what is the solution? That is the advanced machining process. That is the non-conventional machining process or non-traditional machining process. You draw this diagram. Take some time to draw this diagram. Okay. If you are considering the present scenario in an industry, recent trends in an industry like aerospace, missile, automobile, nuclear reactor, like we require the engineering material. Those are having very much superior properties in order to sustain the load, in order to sustain the stresses. It may be a thermal stress, right? Mechanical stress. So we require the engineering material. Those are having very high quality of the properties, like ultra high strength, hardness, very high temperature resistance. That will be the requirement of such material in the application of aerospace, missile, automobile, and the nuclear reactor. But machining of such material, it is quite difficult by using the conventional machining process, where we require the tool which is having a very high hardness. If you are considering ultra high strength, ultra high stainless steel, then that material is having a very high hardness. To machine certain kinds of the material, we require the tool which is having a very high hardness. So, in order to solve such a problem like machining of the workpiece, those are having very high hardness, we require certain solution, and that solution is nothing but the advanced machining process. If we are considering the limitations of conventional machining process, what are the limitations? The workpiece hardness, that is the limitation. Means we cannot machine the material, those are having very high hardness by using the conventional process. Means that the material those are having very high hardness are very difficult to remove the material from such kind of the hard material by using the conventional machine. Second part, that is related to the surface roughness. Surface roughness, it is measured in terms of the surface finish RA value, right? By using the conventional machining, you are not getting the very high surface finish because whatever the material is to be removed, it is in the form of chips. But in case of non-conventional machining, it will be removed in the form of particles or atoms. The next limitation, that is a 3D parts. 3D parts means it is related with the complicated shapes. Complicated or complex geometries cannot be machined by using the conventional machining method. So such limitations are responsible to go for advanced machining process. As if you imagine, if there will be workpiece which is having a very high hardness, if the hardness of the workpiece is more, the time required for the removal of the material from such a hard material, it will be more. So ultimately, it will decrease the economic cutting speed of the machining process. If the economic cutting speed decreases, ultimately it will affect the production. So less number of components are to be produced. Less number of component production, it will be indication of a low productivity. Means if the material or workpiece, it will be having a very high hardness, it will consume more time for the machining and it ultimately affect the production rate of that machining process. Then due to the non-conventional machining, right, the heat is to be generated and because of that heat, rapid improvements in the properties of the material is to be observed. Which are those? That will be the hardness of the workpiece in certain area because of high temperature. We may study it in metallurgy, right? Surface treatment, strength of the uh, we may called as a heat treatment, right? Heat treatment of the material is to be carried out. Because of that, certain portion of the material workpiece material, it will be become hard, brittle, or strength is to be increased. That will be the limitation of this non-conventional process. As we know that tool material that will require very high hardness in order to remove the material from the workpiece which is having a high hard. If we require the superior quality of the tool material or if you require high quality of the surface finish, at that time you go for the advanced machining process. Metal and non-metals, if you are considering metals and non-metals like stainless steel, high strength, temperature resistance, super alloys, such metals which are having a very high strength, they are unable to machine by using the non-conventional process. Tool material you require very high hardness as compared to the hardness of the workpiece. Requires much superior quality of the tool material. That is a we require high quality and high hardness tool material during manufacture processing of the workpiece. Now, what are the product requirements if you are consider in case of the advanced manufacturing process or non-conventional machining or non-traditional machining process? केव्हा आपण हे वापरणार? When you require the complex shape, is complex geometry. We may require the drill which is having a diameter in microns. When it will be required? Machining in unaccessible areas. Means you are drilling a bore, and in that bore again you have to drill a hole which is a parallel to the surface of the workpiece or perpendicular to the surface of the workpiece. So unaccessible area, when you have to machine, that will be not feasible by using the conventional machining. Then when there will be a requirement of a low tolerance up to 10 microns, it will be not feasible by using the non-conventional process. Similarly, when better surface integrity is to be required, there will be no defect, surface defect is to be present on workpiece. It is not possible by using conventional machining process. So we go for non-conventional or advanced machining process. Likewise, when you require the surface finish, which will be a very high, up to the nano level RA value, means nano microns. Like a surface finish, if you require at that time, you go for the non-conventional machining process. Then miniaturization of the product, it will require non-conventional. High material remove rate, that will be not possible by using the conventional machining process. Means these are the certain requirement of the workpiece or product where conventional machinings are not suitable. There are certain limitations for the conventional machines to satisfy such product requirements where you must have, we must need the non-conventional machining process or advanced machining. Write down these points. Or then there are certain processes where we require the high rate of the production, or in case of the mass production, in case of the mass production or high production for the material, those are very difficult to machine. In such process, we again go for the advanced manufacturing process, machining process, low cost production, precision and ultra precision machining or nanometer machining. For such cases of the machining processes, we require advanced machining process. When we require the material removal in the form of atoms or molecules, because when the material is to be removed instead of the chips, it will be in the form of atoms or molecules. Definitely, it will give the close tolerances of the dimensions and very high surface finish in terms of the nanomicrons. It will be achieved only and only by using advanced machining processes. This previous slide and this slide, it is in continuation. Means when the product requirement is like this, at that time conventional machining processes are not suitable for such kind of the product requirement. You must have to go for the advanced machining processes. Continue this point with the previous slides. Okay, we'll see certain examples where we require the advanced manufacturing or machining processes. As we told in previous slide, when there will be a certain complex shape is to be provided to the workpiece. At that time, we go for the advanced manufacturing process or non-conventional process. If you are observing this diagram, turbine blade, right? Turbine blade with the cooling hole. Here, this will be the blade, and this will be shows the thorough hole to this turbine blade in order to provide the cooling air. This will be the suction side, and the burn gases it will be passing over this turbine blade. Because of that, the temperature of this turbine blade it will be increases, and it may affect the properties of this material. So, in case of the turbine blade, we require the high strength material for the manufacturing of the turbine blade. But in order to maintain the temperature of that blade, we are providing certain holes through which cooling air is to be passed. Here, this will be the one hole, and that will be thorough throughout the hole, throughout the blade. And one hole, it will be looking like this. So such complicated shape is to be formed by using the electrochemical machine. Right? If you are observing here, hole normal to the wall. If this will be the hole and this will be the wall. When you have to make a hole normal or perpendicular to the wall, you again go for the non-conventional machine. Contour hole drill in a inconol using electrochemical machine. Similarly, this will be the job where this will be the female and this will be the male. It will be completely fit with this geometry. To make a certain complicated or complex shape, we go for the precision wire ADM, means wire cut electric discharge machining. It can easily produce certain kind of the jobs. Then tapered 3D cutting using traveling wire cut ADM. This 3D cutting means three-dimensional cutting. You are having a large dimension at the base, and as we goes on altitude wise, the taper is to be provided for the certain region, and that will be possible by using the non-conventional machining processes. These are the certain examples that I have shown in the form of figures in order to get why we need this non-conventional or advanced or non-traditional machining processes. I think you're getting certain idea that why you have to study this non-conventional machining process, because certain shapes we cannot prepare by using the conventional lathe machine, drilling machine, grinding machine, boring machine, right? Like this, like this, right? So there are certain limitations for the conventional machining process in order to provide certain complex geometries of the workpiece where you can use non-conventional machining process. Again, there will be one slide. It will show what is the density of the holes and what will be the size of these holes that will be prepared on a material or workpiece. Part of the helicopter turbine, holes drilled by the EBM. What is EBM? Electron beam machining. What this figure shows? This is the helicopter turbine part, and we are providing number of holes of complex geometries here. These are the number of holes: large size, small size, certain irregular size. Right? Such holes are to be produced by using the electron beam machining. If you are considering this slide, what is, see the diameter of that hole and how much is the density of that hole. 0.09 mm is the diameter of one hole, right? And what is the density of that hole? Near about 4,000 holes in a 1 centimeter square area. And what is the material for this workpiece? That is the stainless steel. What is surface finish? 10 micron. Time required 10 microseconds per hole. And what is thickness of this plate? That is 0.2 mm. See here, how much how much thickness of this plate? It is a very small thickness, 0.2 mm, not a complete 1 mm. See here. And within a small area, how much density of the hole with a very small diameter and within a small time for a very high hardness or high superior quality workpiece, that is stainless steel. Such holes are manufactured by using EBM, electron beam machining. If you are consider here, see the diameter of the hole, 0.006 mm, means 6 micrometer. Density here, 2 lakhs per centimeter square. Thickness 0.12 mm and time 2 microseconds. See here, what is the magic that will be prepared by using the electron beam machining? How smaller size holes are to be produced? What will be the its density within a very small area? 1 centimeter square area म्हणजे 1 centimeter by 1 centimeter हा एक चौकोन आखला तर त्याच्यामध्ये 2 लाख होल्स प्रोव्हाइड करते. That is really magic, right? Then We just discuss about the some important characteristics of this advanced manufacturing processes and machine process. Whatever the machining processes we have studied, they are having a independent performance irrespective of the strength. Secondly, the performance of such processes it will be depend on workpiece material properties of the workpiece material. Which properties are those? It may depends on a thermal properties of the material. It may depend on magnetic or electrical properties of the material. Also, it affects the performance by considering its chemical properties. In non-conventional or advanced machining processes, we may use different form of energy. It will be in a direct form as well as in indirect form in order to produce certain source of energy to remove the material from the workpiece. In general, if you are thinking about the conventional and non-conventional process, in case of the conventional process, we are removing the material from the workpiece in the form of the chip. So the material remove rate it will be more in case of a conventional machining process. लेथ मशीन मध्ये पाहता तुम्ही वर्कपीस वरनं मटेरियल काढायचं म्हणले की चिप्स तयार होती बरोबर आहे गुंडोळी तयार होऊन जाते म्हणजे rate of the material removal it will be more because material is to be removed in the form of chips, but the quality of the surface finish it will be not good, it will be poor. Whereas in non-conventional machining, as we discussed that material is to be removed in the form of atoms or molecules. So the it is having a low material removal rate, but we are getting the quality of the finished product. It is a very superior. It is in a micro nanomicron. Sorry, it is in a nanomicron. So very high surface finish is to be obtained by using the non-conventional process. But there will be certain limitations. Comparatively, high initial investment cost is to be required for certain kind of the machine tools, and to operate such kind of the machine tools, we require the skillful workers. So operating cost it also more. Also, it requires certain accessories like coolant, right? Like abrasive particles, like slurry, like pump. It will be required. So operating cost ultimately it will be more as compared to the non-conventional machining process. So it is all about the mm, need why we require this non-conventional machining process in a field of engineering, in a applications, various applications of the engineering. So we may refer this advanced machining process by V.K. Jain, Allied Publisher Private Limited, to take notes, to form the notes why we need the advanced machining processes. Okay, I think you might have clear why we require the advanced machining process or non-conventional machining process or non-traditional machining process. All these three words are having same meaning. Which are those? Non-conventional, non-traditional, and advanced machining processes. Are we getting? Anybody have a doubt regarding this point? Yes, Pradyun.
No, sir.
Okay. Till today, present is very less. Only 25 are present. Sanket, his point is clear. You understood why we require the non-conventional processes? Okay. Abhishek. Abhishek is there. Abhishek Shivsagar. Swapnil. Roll number 65. Are you there? Okay. Swapnil. Okay. All are requested to write your roll number in chat box. Is it over? I think everyone have written your roll numbers in chat box. Okay. Uh, Discuss with your friends. Ask them to join the lecture because your term work it is based on your attendance from day first. I am requesting you to maintain the attendance as per the requirement. I am not adjusting any single attendance. If you are coming to me, I am becoming a defaulter. Please increase my attendance by one lecture. It is not possible from my side. So I am requesting you to be present during the scheduled time of the lecture. So it will be not difficult for you and me also while giving the term work by considering the attendance. Okay, everyone have written your roll numbers or name in a chat box. Roll number. Okay. So with this,